Radiochemistry and Isotope Group, Bhabha Atomic Research Center, Mumbai, and Vice President, Indian Association of Nuclear Chemists and Allied Scientists. As I was just talking to Sir during a cup of tea in my office, Sir has some very nice and wonderful ideas for our young faculty members as well as our students to be associated with the BARC Institute in Mumbai. So we will be interacting with Sir, and I'm sure all of you will be interacting with him to understand how we can move forward after your MSc from here to bigger institutes of research. I welcome Dr. P.C. Kalsi, who is on his way and will be joining us soon, the Executive Member, Indian Association of Nuclear Chemists and Allied Sciences, and former Senior Scientist of BARC, Mumbai. Dr. Singh, who is also on his way, Secretary of the...
For me to welcome Dr. Kanan, who is the Director of such a prestigious Institute of India, and we are really happy that we are going to talk about a subject which is of a great importance in the modern times. You see, most of the people don't appreciate why we are doing it. You see, the Sikh Education Society is doing seminars and writing lectures from all over the areas to talk to their students. And Sikh Education Society has got a very big advantage that is headed by an IIS officer, Mr. Puran, and by a person who has got a lot of knowledge about administration, Colonel Bhabha. So, Dr. Khan, you are...
Next, sir, I will give you a few slides about the application of isotopes in hydrology. Anyway, very good morning. Respected Professor Kaur, Principal, Sri Guru Gobind Singh College, Chandigarh, and Engineer Surendra Singh with the EC member, Sikh Education Society, and Professor Kulvinder Singh, Dean Sciences, and Professor P.C. Kalsi, and Professor Tamindra Singh, and Professor Mehta, and welcome you all for this IANCAS 2 days national workshop. As you know very well, the IANCAS, that is Indian Association for Nuclear Chemists and Allied Scientists, it has completed almost 50 years. Yes, it was started in 1981. We are running up 50 years. And we used to conduct, that is national workshop, that is 5-day workshop, yearly thrice. And this is fully funded by the BRNS, that is Board of Research in Nuclear Sciences. And every year we do 3 workshops. So we have completed around 106 workshops so far. And also we used to conduct 2 days workshop. And we have school workshops also, 1 day school workshop. The purpose of the workshop is to educate the field of nuclear science and technology to the college people, that is for school workshop. And the 2 days workshop are mostly for the MSc students, and the 5-day national workshop are the professors, that is the young faculty and PhD scholars and some of the MTech students. As you know, the purpose is that people, atomic energy means people always feel something, something negative in the mind. Okay, so this, you can see, of course, there are 2 parts for everything. For a coin, you have 2 parts, tail and head. Similarly, take the atom, you have 2 parts. Today, we will discuss it mostly on the positive side. Of course, negative side is there, but of course, that is...
I want to share some of my experiences with you based on when a student in BSc is introduced to the nuclear physics experiments, he has to be specially trained for those things. Baki jo experiment, they do in a normal way, they do the measurements in temperature, magnetic field and other things. But here you work with the statistics. So there you have to have different temperament, different time management, how to get the best results with the minimum error within the specific time. That kind of temperament has to be inculcated among the students. That's very, very important. It's not like that you do some element to care about systematic analysis is one important aspect, and the repeatability and the spread in the distribution is another aspect. Another thing I would like to share with Sal that experiments should be introduced at the school level also. Without the radioactive sources, without
an accelerator which we have housed in this building that we imported from Netherlands. So it was supplied to us by high voltage engineering. So these are the glimpses of the various components while installing that facility at Kurukshetra University, because Kurukshetra University is a state university, and in our system there is always dearth of resources in state universities. So it's a big thing that we have in Kurukshetra. So you can see here that the engineers itself came from Netherlands to install this system at Kurukshetra. So this is the 200 kilo electron volt ion accelerator which we have at Kurukshetra, and it is open for all the students who want to do research in material science. Okay? And it's a big thing for us, but if you talk about people from BARC or from IIC, they have plenty of such accelerators. Okay? Even your neighboring institute, I think they have cyclotron accelerator at Punjab University, Chandigarh also. But this is a new system and it's a computer controlled system. So I'll be talking about its advantages later on. So this is the aerial view of this system. Now coming to, so this was funded by DST. Now coming to the topic of which I have been entrusted with today, that is introduction to radioactivity. So I'll start this topic by remembering some of the early pioneers in radioactivity. You can recognize all of them probably. He is Rutherford, who discovered alpha particles, then Bronson, who discovered X-rays, and Curie-Couple, who discovered radium and polonium, and then Becquerel, discoverer of radioactivity, about which I'll be talking about in a few moments from now. So what is common in this picture? What is common to all of these people?
All are radioactive.
Since you all are students, so my lecture is mostly for the students sitting beyond these sofas. So let's make it a dialogue, not a monologue. So what do you think is common in this picture with everybody here? Nobel Prize. Yes, ma'am, you have said it very rightly, that all of them are Nobel Prize winners. Okay, and I hope all of you know, being physics students, you know that Nobel Prize is given for some exemplary work which is for the benefit of humanity. Okay, so that shows all the work which these people have done that has affected or that has helped humanity in a big way. So that shows the importance of radioactivity which we are going to talk about today. So radioactivity, if you talk about anything nowadays like health physics, journal, even fire alarms, power supply, because all the things which we are dependent on today depends upon energy, and radioactivity or nuclear physics is a pillar on which all these things are standing today. Dr. Mehta also said very rightly that nowadays medical physics, it's coming out in a big way. Okay, a lot of their students also, a lot of our students from Department of Physics, Kurukshetra University, they are opting for, after MSc Physics, they are opting for courses in medical physics. Like I had an interview for radiation safety officer at BARC. I was staying in the guest house. I met there 3 of our students who were doing these courses at BRC. Although the admission process is quite cumbersome over there, you have to be at the top to get an admission there. But you see, everything which has a market value, students want to do that. Okay, so these courses are the need of the hour, because PGI, your neighboring institute, has a big department in nuclear medicine. So these courses definitely students should opt for. And students are doing them after MSc Physics. Okay, so I think it's a good opportunity for all of you to interact with scientists from BARC, so that you should know what are the dimensions of the opportunities which are waiting for you to grab. Even if you see that ICTP, have you heard the name ICTP? ICTP सुना है ना? चलो आप सब गूगल कर लेना. ICTP, it's an answer that why DM counter can detect beta particles, why we cannot use it for energy spectroscopy, because we know that DM counter does not give us information about the energy of the charged particle. It's just a counter, so it detects only. So those informations will be, I don't want to, there will be a lecture on that also.
Okay, thank you.
कोई बात नहीं बेटा
मैम जो एयर में मैम आज प्रेजेंट
You see, I think CND is doing wonderful work by studying radon studies.
फोटोग्राफर बना के रखा हुआ
Study कर रहे हैं तो air में हमारे there are some radioactive elements present in bricks also, soil also. So all
Smart city scheme, they put compulsory for the so the water flood, you can convert it into non-agricultural agriculture, fertilizer. So, if you come to nuclear power, the global scenario, the nuclear energy contributes 25%. You can see the geothermal is 2%, biofuel is 10%, petroleum is 22%, natural gas 20%, coal is 27%. So now you know, when our preliminary stored in this one, by 2070, it is zero carbon. That means there is no carbon beyond 2070. Because the carbon, you know very well, the carbon dioxide pollutes the environment, global warming, the temperature of the earth will rise by 2 to 3 degrees, 2 to 3 degree increases, then melting of Arctic and Antarctica ocean, then water level increase. Most of the cities which is on the coastal, everything is covered. So you have to avoid the carbon-based fuel. At least by another 20 years, that is by 2040, it will be 50% reduction. So how to go faster? So other way to this, according to us, release the nuclear one. In Indian, you see Indian scenario, so we have the Indian scenario, because in the blue one, 60% is from thermal. That is like coal. And hydro is 12%, solar is 12%, wind is 10%, and nuclear is only 2%. Okay? Then, these other countries, we compare with the developed countries like USA, they have, you can see nuclear is around 20% and coal is 39%. And in France, you can see nuclear is 62%. Okay? Then in physics India, the nuclear power, as on today, we have 22 reactors, we generate around 6,180 megawatts. And we are planning to construct 10 more reactors. Like in BARC police also in Haryana, we are planning to approach, they are not getting the good quality glass. So how to see that is uniformly mixing or not? Simple isotope, use a technician isotope, you put the mixture and you say, of course, this is how the uniform is mixing or not. We found out that the problem with the blade, which is mixing the mixture. You can identify and rectify the problem. Now they will get a high quality product. So some of the application is heat detector in buried pipeline, high pressure heat exchanger, flow rate measurement, mixing of melting. Of course, this is not the one we have written for this one. Resonant and distribution measurement, radioactive particles. So some of the technique which can be useful for industrial techniques. Then isotope catalysis. So this is very important. That's what our professor has told me in the morning. That this is very important though, because now you know water is a problem. Particularly some of the reasons I believe dry in summer, whereas in winter season we are having a lot of this. I don't know any problem. I think Chandigarh there is no problem. You go to Andhra Pradesh, Tamil Nadu, it's always dry. Only in the rainy season you get the water. So how to find out the source? So one of the ones you can see here that isotope water source management. You may not believe that I told you in the innovative talk. Yes, monthly I am getting 4 to 5 letters from the Minister of Water Resources. You want this problem, you can use it. So we got sent our scientists to go to the place and find out what is the source, how to work. So the identification of source and origin of groundwater sources, identify the recharge area, that is the surface water groundwater interconnection, estimation of residence time of groundwater, identification of source, mechanism and pathway of the groundwater contamination. Of course, this is like uranium contamination is there. In Punjab, they are telling that uranium contamination. What is the origin process? Whether it is in the nature or the fertilization used in Punjab. So this water catalysis will come. Isotope catalysis. And also identification of origin of geothermal water. See, these are examples. This approach to Uttarakhand, that we know this spring, which is getting dried in summer, whereas the rainy season then. So how to solve the problem? Then the side effect medical may go on. Nowadays medicine is coming in that it is specific to the arm. Okay? And the technician are using for diagnosis. That will go to the vein, but the half-life is only 6. birth. और जाएगा तो 6 months बाहर आ जाएगा. You know the body is its own mechanism to dilute. You see the body, I have not shown the photo. The moment technician is there, after 2 hours you will see most of that will be immediately the kidney. Because it comes out. So wherever there is the cancer cell, there will be the intensity more comfortable. So doctor will see the image, take the gamma screen. Okay, this is the cancer. So this tell me growth. ठीक है?
आपको आप रोटी आ गए
Fruits और vegetables जो आप
अभिलाषी को हाउस हो गई
हाँ?
हाउस उसका प्रोसेस क्या है एक्चुअली
जनरेशन क्या है? टाइगर फूड में टाइगर आपको मिसिंग क्या है? इसके काम आ रहे के दूसरे करें.
मतलब ऐसा करते क्या है कि उसकी लाइफ बढ़ जाती है उसमें
जी बेसिकली किल का पैथोजन है. राइट? मेडिकल प्रॉब्लम.
कुछ ऐसे प्रोडक्ट हो जिनका पैथोजन जरूरी है उसमें होना ना भी हो मूंगफली जैसे ऐसा क्या करेंगे उसकी लाइफ बढ़ जाएगी. बैक्टीरिया नहीं होगा ऐसे प्योर
स्टेरिलाइजेशन दैट्स द थिंग. स्टेरिलाइजेशन किल का पैथोजन. इसको डोज ज्यादा है. आई टोल्ड
तो बैक्टीरिया भी होंगे उसको उनको भी किल कर देता हुआ है तो उसकी क्वालिटी को भी डिक्रीज कर देता होगा.
सुना नहीं ड्यूटी एंड वैल्यू इंटरैक्ट. दैट्स अ ड्यूटी. See that is the dose is very important. You want to see to achieve that kill the pathogen and bacteria. And the nutrient value to be maintained. So nutrient value gaya means nobody uses it. That's the thing. See involved RSO. You see the algorithm of 10 grade rate करो 20 grade. Then they optimize the dose.
वो डोज ही नहीं देते हैं आपकी हमारी से वो जो आप बोल रहे हैं
Yeah, nutrient value भी इंटरैक्ट. ऐसा नहीं blindly ऐसा नहीं. तो मेडिकल प्रोडक्ट का 20 kg करता है. अरे सेम थिंग आपका कहानी है. और मैक्सिमम रिसेंटली लास्ट ईयर भी एक्सपोर्ट
ਅਸੀਂ ਡੇਲੀ ਨੀਡਸ ਯੂਜ਼ ਕਰਦੇ ਹਾਂ ਡੇਲੀ ਲਾਈਫ ਦੇ ਵਿੱਚ ਆਲ ਥੀਸ ਥਿੰਗਸ ਦੇ ਕੰਟੇਨ ਐਗਜ਼ਾਮਪਲ ਤੁਹਾਡੇ ਘਰਾਂ ਦੇ ਵਿੱਚ ਮਾਰਬਲ ਲੱਗਾ ਹੋਇਆ ਮਾਰਬਲ ਜਿਹੜਾ ਰੇਡੀਏਸ਼ਨ ਜਿਹੜੀ ਉਹ ਛੋੜਦਾ ਠੀਕ ਹੈ ਜਿਹੜਾ ਗ੍ਰੇਨਾਈਟ ਹੈ ਉਹ ਵੀ ਰੇਡੀਏਸ਼ਨ ਜਿਹੜੀ ਉਹ ਛੋੜਦਾ ਜਦੋਂ ਵੀ ਮਾਰਬਲ ਤੁਸੀਂ ਲਗਾਉਣਾ ਹੈ ਤਾਂ ਤੁਹਾਡਾ ਜਿਹੜਾ ਕਮਰਾ ਹੈ ਓਪਨ ਹੋਣਾ ਚਾਹੀਦਾ ਤਾਂ ਕਿ ਰੇਡੀਏਸ਼ਨ ਉੱਥੇ ਜਿਹੜੀਆਂ ਟਰੈਪ ਨਹੀਂ ਠੀਕ ਹੈ ਜੇ ਰੇਡੀਏਸ਼ਨ ਟਰੈਪ ਹੋਣਗੀਆਂ ਤਾਂ ਤੁਹਾਨੂੰ ਨੁਕਸਾਨ ਕਰੇਗਾ ਉਹ ਨੈਚੁਰਲ ਰੇਡੀਓ ਐਕਟੀਵਿਟੀ ਹੈ ਉਹਨੂੰ ਤੁਸੀਂ ਅਵੋਇਡ ਨਹੀਂ ਕਰ ਸਕਦੇ ਬਟ ਅਸੀਂ ਉਹਦਾ ਯੂਜ਼ ਜਿਹੜਾ ਹੈ ਉਹ ਤੇ ਜਸਟੀਫਾਈਡ ਤਰੀਕੇ ਦੇ ਨਾਲ ਕਰ ਸਕਦੇ ਠੀਕ ਹੈ ਹੁਣ ਜਿਵੇਂ ਵੀ ਆਰ ਟੇਕਿੰਗ ਦਿਸ ਮਿਲਕ ਪਾਊਡਰ ਵੀ ਆਰ ਟੇਕਿੰਗ ਮਿਲਕ ਔਨ ਡੇਲੀ ਬੇਸਿਸ ਅਸੀਂ ਦੁੱਧ ਜਿਹੜਾ ਪੀਂਦੇ ਹਾਂ ਸਾਰੇ ਬੱਚੇ ਪੀਂਦੇ ਹਾਂ ਮਾਵਾਂ ਤੇ ਜਿਹੜੀਆਂ ਲੰਬੇ ਪਾ ਕੇ ਦੁੱਧ ਪਿਆ ਦਿੰਦੀਆਂ ਨੇ ਦੁੱਧ ਪੀਓ ਹੁਣ ਇਹਦੇ ਵਿੱਚ ਵੀ ਰੇਡੀਓ ਐਕਟੀਵਿਟੀ ਹੈ ਠੀਕ ਹੈ ਉਹ ਤੁਹਾਨੂੰ ਮੈਂ ਜਸਟ ਸ਼ੋਅ ਕਰਾਂਗਾ ਕਿ ਕਿਸ ਤਰ੍ਹਾਂ ਰੇਡੀਓ ਐਕਟੀਵਿਟੀ ਹੈ ਜੀਐਮ ਪਾਊਡਰ ਹੈ ਯੂ ਆਲ ਨੋ ਦੀ operation and operating of this GM counter how to operate. ठीक है एनी ऑपरेटिंग मोड एक सेट किया हुआ है जिस ऑपरेटिंग मोड है even 1000 भी हो रहा है then I am incorporated 30 seconds का टाइम है just start to find क्या कितने काउंट्स दे आ सो ਇਹ ਕਿਹੜੇ ਕਾउंट्स ਨੇ GM काउंटर ਕਿਹੜੇ ਕਾउंट्स ਜਿਹੜੇ ਉਹਨਾਂ ਨੂੰ ਗਿਣਦਾ that is the beta radiation ਜਿਹੜੀ ਉਹਨੂੰ ਕਾਊਂਟ ਕਰਦਾ ਇਹਦਾ ਮਤਲਬ ਕਿ ਦੇਖੋ beta radiation ਜਿਹੜੀਆਂ ਨੇ ਇਹਦੇ ਵਿੱਚ ਕਿੰਨੀ ਹੋਊਗੀ ਠੀਕ ਹੈ I have taken a pinch of milk powder ਠੀਕ ਹੈ but this is not harmful ਇਹ ਸਾਡੇ ਵਾਸਤੇ harmful ਨਹੀਂ ਹੈ ਜੇ ਅਸੀਂ ਰੇਡੀਓ ਐਕਟੀਵਿਟੀ ਨੂੰ ਕੰਜ਼ਿਊਮ ਨਹੀਂ ਵੀ ਕਰਦੇ ਤਾਂ ਵੀ ਉਹ ਸਾਡੇ ਵਾਸਤੇ ਨੁਕਸਾਨ ਨਹੀਂ ਹੈ ਥੋੜ੍ਹੀ ਬਹੁਤੀ ਰੇਡੀਓ ਐਕਟੀਵਿਟੀ ਸਾਨੂੰ ਚਾਹੀਦੀ ਹੈ ਠੀਕ ਹੈ ਸੋ ਇਹ harmful ਨਹੀਂ ਬਟ ਸਟਿਲ ਇਹ ਮਤਲਬ ਜੇ ਅਸੀਂ ਕਹੀਏ ਕਿ ਅਸੀਂ ਮਿਲਕ ਪਾਊਡਰ ਹੀ ਹਰ ਵੇਲੇ ਯੂਜ਼ ਕਰੀ ਜਾਈਏ ठीक है ਜਾਂ ਇਹੋ ਜਿਹੀਆਂ ਚੀਜ਼ਾਂ ਜਿਨ੍ਹਾਂ ਦੇ ਵਿੱਚ ਰੇਡੀਓ ਐਕਟੀਵਿਟੀ ਹੈ ਜਸਟ ਸੇ ਕਿ ਕਿੰਨੇ ਕਾਊਂਟਸ ਦੇ ਆ ਗਏ ਸੋ ਚਾਕਲੇਟ ਜ਼ਿਆਦਾ ਨਹੀਂ ਖਾਣੀ ਇੱਕ ਤਾਂ ਦੰਦ ਖਰਾਬ ਕਰੇਗੀ ਉੱਤੋਂ ਦੇਖੋ ਉੱਤੋਂ ਤੁਸੀਂ ਰੇਡੀਏਸ਼ਨ ਰਿਮਿਟ ਕਰੋ ਇਹ ਨਾ ਹੋਵੇ ਕਿ ਚਾਕਲੇਟ ਖਾ ਕੇ ਬੀਟਾ ਸੋਸ ਹੀ ਪਹੁੰਚ ਜਾਵੇ ਘੱਟ ਖਾਇਆ ਸਾਡੇ ਕੋਲ ਕਿੰਨੀ ਯੂਨਿਟ ਐਜ ਮੈਂ ਇੱਕ ਪਿੰਚ ਆਫ ਪ੍ਰੋਟੀਨ ਤੇ ਤੁਸੀਂ ਕਿੰਨੀ ਖਾਣੀ ਹੈ ਇੰਨੀ ਤਾਂ ਤੁਸੀਂ ਟੇਸਟ ਕਰਨ ਦੇ ਵਿੱਚ ਹੀ ਲਗਾ ਦਿਓ ਤੇ ਵੀ ਸਵਾਦ ਹੈ ਸਵਾਦ ਦੇ 5 ਹੋ ਗਏ ਹਾਂਜੀ
ਸਰ ਚਾਕਲੇਟ
ਤੁਹਾਡੇ ਕਾਲਜ 'ਚ ਕੋਈ ਮਿਲੀ ਨਾ ਨਾਲ ਨਾਲ ਲੈ ਲਈ ਜੇ ਤੁਸੀਂ ਡਿਮਾਂਡ ਕਰੋ ਨਾ ਕੰਟੀਨ ਵਾਲਿਆਂ ਨੂੰ ਕਿਹੜੀ ਮੈਂ ਨਾਲ ਤਾਂ ਨਹੀਂ ਲੈ ਗਿਆ ਸੋ ਠੀਕ ਹੈ ਦੇਖੋ ਤੁਸੀਂ ਕਿਸੇ ਵੀ ਚੀਜ਼ ਇਸ ਤਰ੍ਹਾਂ ਨਾਲ ਜਿਹਦੇ ਵਿੱਚ ਰੇਡੀਓ ਐਕਟਿਵ ਐਲੀਮੈਂਟਸ ਹੈਗੇ ਆ ਤੁਸੀਂ ਇਸ ਤਰ੍ਹਾਂ ਉਹਨੂੰ ਦੇਖ ਸਕਦੇ ਹੋ ਕਿ ਉਹਨਾਂ ਦੇ ਵਿੱਚ ਰੇਡੀਓ ਜਿਹੜੀ ਉਹ ਠੀਕ ਹੈ ਜਿਸ ਤਰ੍ਹਾਂ ਮੈਡਮ ਸਾਨੂੰ ਨੇ ਤੁਹਾਨੂੰ ਕਿਹਾ ਸੀ ਕਿ ਦਿਸ ਇਜ਼ ਦੀ ਨੈਚੁਰਲ ਰੇਡੀਏਟਿਵਿਟੀ ਤੇ ਤੁਸੀਂ ਇਹਨੂੰ ਮਤਲਬ ਬਚ ਨਹੀਂ ਸਕਦੇ ਇਹਦੇ ਤੋਂ ठीक है, जी नेचुरल रेडियोएक्टिविटी वो तो है ही, वो नेचर के है ही, वो बच नहीं सकते चीज़ कि इसका जस्टिफाइड यूज जोड़ा है सर ने जो दसिया कि जिमें असी मैडिकल के यूज करते हैं रेडियोएक्टिविटी ट्रीट कैंसर, फिर असी एक सवाल पूछा कि जोड़ा असी उन्होंने ट्रीट करते हैं रेडियोइसोटोप्स के नाल कि वो बैक्टीरिया जोड़े गुड बैक्टीरिया नहीं मारता, नहीं गुड बैक्टीरिया नहीं मारता, वो न्यूट्रिशन वैल्यू भी नहीं खत्म करता, इस करके कि वी यूज दी कंट्रोल्ड डोज। असी वो एक्सपैरीमेंट करके देखा होया कि यह जो पीनट है कि असी इन्ने ग्रे की रेडिएशन पाइए तो उसका की इफेक्ट होएगा, इन्ने पाइए तो की इफेक्ट होएगा।
The opportunity to be here organized this morning, sharing my views on various nuclear radiation detectors. And I'm thankful to the principal organizers of the college and especially to the Puran Singh Society, Dr. Puran, of course, and all the colleagues of the college and director principal of the college for giving me the opportunity to be organized. But what I'm saying is, of course, the less presence of the students here today. Maybe the people are slightly relaxed today being Sunday. Anyway, so what I'm part of is, as we discussed yesterday, various detectors. So I'll let you know mainly basically two set of detectors which we have used yesterday, and I'll throw a light as quickly as possible. So, as we are aware, various nuclear radiation detectors, they are mainly composed of various gaseous detectors, and in the gaseous detectors we have our radiation sample proportional constant. Variation of the electric field, variation of the electric field between the two electrodes has to be quite symmetric, as was the case of the proportional constant. And that's why we generally use the 4-pi geometry. No other geometry is required as well as the elliptical or any other geometry to be used in all these counters. And the function of the proportional ionization counters, of course, for exposure and absorb those measurements in terms of what they call as in medical the gray, the units of gray and Rungens, they are used nowadays. Rungen is a watt meter, gray is again a watt meter. But earlier days they have been using the exposure in terms of exposure X, which is very big unit in terms you can think out to be a 1 coulomb of the charge per kilogram of air. But we are using the air in ionization. So when you think of the modern unit like Rungen, very modern, very less as compared to exposure. And if I think of the one the Rungen, angle of flight is also important. So these are three set of criteria which are significant. So that's again, we'll say track forming material and non-track forming material. So these have a very high resistance. We consider them a track forming material like all the insulated glasses and plastics, as we said. And all the semiconductors or most of the basically conductors, they are non-track forming because they don't have high resistance to stop the radiation. So that's what we try. Now, if I see the main what we call the various model for exploration, then the best model which has been put forward nowadays, there are displacement spike, there is a thermal spike, there is a restricted energy loss. The best model to explain a track in solid is what we call as ionization, or what we call as ion explosion model. And the basic principle of this model is that when a heavy ion charged particle passes through any insulating solid, as we said, its resistance is very high, this is going to ionize the material again, plus minus ion. Now these plus minus ionization, because of the presence of the very high positive ion, they will repel each other and they are going to make a stress across that material. So that electrostatical stress which has not developed because of the passing of the high ion, ultimately after time when it has passed, it got relaxed, but that stress has created a stress. And that stress ultimately developed by the incoming ion has created the cracks or the damage in the material. So overall you can say cracks will be not formed if your material is not having a very high concentration of the electrons. That's why semiconductors are not used. So overall in this case of the model, this is the best way of explaining the crack formation in the solid. Your electrostatic force must be greater than your local strength.
Anode to cathode to anode, what happens?
Good. Now you can see the radius are different, right? As I said, anode wire is 0.1 mm. chemistry power 4 or 5 or 6, depending upon how much energy you are getting and how much voltage you apply. Now, if I change my cathode to anode, of course, your voltage will not work. Maybe it will work, but you have to change the polarity. But even if you change your polarity, your now anode wire is very thick as compared to being very thin. So when you have a very thick wire, your radii change, and that's the law of the